this is the order of effect of substituent or anomalic effect. Anomalic effect decreases in this order. Halogen shows more anomalic effect, positive anomalic effect. PaCO2 it decreases in this order. If you observe, if there is a N pyridinium group as a substituent, then there is negative anomalic effect. There is negative. The value of anomalic effect goes negative when the substituent is pyridinium, N-pyridinium group. Substituent is N-pyridinium group. Then the anomalic effect goes negative, and due to this negative anomalic effect, this effect is known as reverse anomalic effect. Reverse anomalic effect. Reverse anomalic effect. So the nature of substituent is important. Nature of substituent is very important in anomalic effect while considering the anomalic effect. So magnitude of anomalic effect decreases in this order. Halogen have highest anomalic effect, then N2 plus have lowest, and when there is a N-pyridinium as a substituent, then the effect goes negative, and this is also called as reverse anomalic effect. Reverse anomalic effect becomes negative here. So reverse anomalic effect. So this is about effect of substituent. See, effect of bulk when the substituents are. Third characteristic that we have to study is the effect of bulk. Effect of bulk. So bulk, suppose that substituent is OR. Alkoxy group is the substituent. When the alkoxy group is substituent, then the nature of R, if bulky, then it has no direct effect on anomalic effect, magnitude of anomalic effect. It has no direct effect on the magnitude of anomalic effect. So bulkiest R group doesn't change the magnitude of anomalic effect sufficiently. So the bulky group has no much effect on magnitude of anomalic effect. Magnitude of anomalic effect. Magnitude of anomalic effect. So these bulky groups has no much effect on magnitude of anomalic effect. Magnitude of anomalic effect cannot change when we change the R group. When the substituent is OR, it may be bulkier, but it may be less bulkier. Then it has no effect on the magnitude of anomalic effect. So the effect of bulk. See, this fourth effect, that is effect of solvent polarity. Effect of solvent polarity. So solvent is very important in case of anomalic effect, because the more polar solvent, more polar solvent, the anomalic effect is less. So more polar solvent, the less anomalic effect is inversely proportional. Anomalic effect is less in case of more polar solvent. If solvent polarity increases, the anomalic effect goes on decreasing. So it is important to see the solvent effect. So solvent polarity depends on solvent polarity. That more polar solvent, there is less anomalic effect. So we increase the solvent polarity, then anomalic effect goes on decreasing. When we decrease the solvent polarity, anomalic effect goes on increases. So these two quantities are inversely related. So next is the ExoAnomalic effect. So next point, is the ExoAnomalic effect. ExoAnomalic effect. ExoAnomalic effect. So see this compound. Look at this methoxy substituted compound. Methoxy substituted compound. Methoxy substituted compound. So if we look at this compound, then it is observed that if we look at this compound, then it is observed that there is a gauge interaction. There is a gauge interaction here between the, say this is, we can say carbon number 2. So starting from here 1, 2, 3, carbon number 4, 2, 3, 4, 5, carbon number 6. So look at here, this compound here, gauge interaction between here C6, carbon number 6, oxygen, then carbon number 2, and again another oxygen. So see here, I am broadening this line. The gauge interaction between this. Gauge interaction here between C6, O, C2 and O. There is a gauge interaction here. So if this is a gauge interaction, then it is expected that, see this compound, I am drawing it again. It is expected that the gauge interaction also in between this gauge interaction is also expected and observed here. O, then here C2, O, C2, O, and then here this carbon. So gauge interaction is also expected here, expected and also observed. Gauge interaction is also expected and observed here in this case. So due to this, the oxygen and carbon bond, OC bond, goes away from ring, and this is known as ExoAnomalic effect. This is called as ExoAnomalic effect. This is known as ExoAnomalic effect. So let's see again. ExoAnomalic, we are studying here ExoAnomalic effect. In this ExoAnomalic effect, if you observe this compound, methoxy substituted compound at position number 2. Methoxy substituted compound at position number 2. Here in this position, methoxy substituted compound, if we observe the position of these groups present in this compound, that carbon number 6, then oxygen, carbon number 2 and oxygen, C6, O, C2 and O. There is a gauge interaction, butane gauge interaction, 1,4 interactions. So similarly 1,4 interactions are there, C6, O, C2 and O. There is gauge type of interaction. So we expect that similar interaction between 1 oxygen, 2 carbon, oxygen and carbon. Similar interaction is observed there, and similar interaction expected also observed experimentally this interaction, due to which this oxygen carbon bond go away from the ring, slightly twisted and go away from the ring, and this is called as ExoAnomalic effect. The axial substituent is there, and this axial substituent oxygen carbon bond goes away from the ring due to anomalic effect, and that anomalic effect is known as ExoAnomalic effect. This effect is known as ExoAnomalic effect. Now it is clear. See, the next is double anomalic effect. Double anomalic effect. In double anomalic effect, double anomalic effect. In double anomalic effect, it is generally observed in compound 1,3-dioxane. 1,3-dioxane. Dioxane compound. See here, 1,3-dioxane compound. Here two oxygen atoms are there. 1,3-dioxane compound is there. This 1,3-dioxane compound, if axial substituent is there, axial substituent is there in this position. So axial substituent is there. We see that here axial hydrogens are there. Axial hydrogens are there. Due to axial hydrogens, see, there is a strong synaxial interaction. Strong synaxial interactions in there. Synaxial interaction is there, but here due to two oxygen atoms present, in spite of this strong synaxial interaction, synaxial interaction, this preference is given to axial position of substituent. Position of substituent, axial position of substituent, and this is due to the double anomalic effect. Double anomalic effect. So this is called as double anomalic effect, where the axial position, the substituent is present in axial position, but here double anomalic effect is there. That's why this axial position is stabilized. We know that in anomalic effect, the extra preference is given to extra preference is given to axial orientation at position C1 or C2. C1 in aldoses, C2 in ketoses. So extra preference given to this axial orientation, and this is called as anomalic effect. And here double anomalic effect is there because two oxygen atoms present, and next to these two oxygen atoms there is a anomalic carbon where the substituent present in axial position, and due to axial position the preference is given, and this axial conformer predominates, or we say axial conformer is more populated than the equatorial conformer, and this is due to the double anomalic effect. This is called a double anomalic effect, due to which the extra preference is given to the axial position of the substituent. So double anomalic effect is here. So in this way we have studied the characteristics or some relative effect of anomalic effect, that is ring size, ring system, and anomalic effect. You know that there are certain rings such as pyranos, tetrahedropyran shows such type of effect. Second, effect of the substituent. The substituent, nature of the substituent has much more effect on the anomalic effect. So there is certain decreasing order starting from halogen, then pH, CO2, ACO, ACS. In this way the order decreases, and when the substituent is N-pyridinium, then the effect is negative, and we call it reverse anomalic effect. That is the effect of bulk. If the substituent is OR, alkoxy group, and substituent is bulky, R group is bulky, then it has no much effect on anomalic effect. So bulky bulkiness of that R group doesn't affect the anomalic effect, likelihood of anomalic effect. Solvent polarity has much effect, because when solvent polarity increases, the anomalic effect decreases. So it is inversely proportional. So solvent polarity when we decrease, the anomalic effect increases. ExoAnomalic effect, we know that ExoAnomalic effect, the Gauge interaction is there, and due to Gauge interaction, oxygen carbon bond goes away from the ring, and that is well pronounced effect. We call it ExoAnomalic effect. Double anomalic effect in 1,3-dioxane, the axial position is more preferred in spite of the strong synaxial interaction is there. Still it exists in the axial form, so axial conformer is more populated than the equatorial conformer. Axial conformer is more populated than equatorial conformer, and this is due to the double anomalic effect, and this is called double anomalic effect. So this is about anomalic effect. Let's see the next point. That is heterocycle with 6-membered heterocycles with nitrogen or oxygen. Heterocycles with nitrogen or oxygen. So heterocycles with nitrogen or oxygen. So next point we have to study is the 6-membered heterocycles with nitrogen and oxygen. See here 6-membered heterocycles with nitrogen and oxygen. Six-membered heterocycles with their nitrogen and oxygen. Suppose that X is there. So this is piperidine compound. Piperidine compound. And this is morpholine compound. So these are 6-membered heterocycles containing nitrogen, and here nitrogen and oxygen. Nitrogen and oxygen. So morpholine and piperidine that we have to study here in this case, and see the conformational analysis of these two, piperidine and morpholine, and we have to compare it with cyclohexane. Compare it here with the cyclohexane. Now in these compounds, we have to see the bond length of carbon-carbon, then bond length of carbon-oxygen, bond length of carbon-nitrogen. Then if we observe the bond length of these three, carbon-carbon, carbon-oxygen, carbon-nitrogen, then they are nearly similar. Bond length, and also the bond angle between carbon and carbon, also carbon, oxygen and carbon, so carbon, nitrogen and carbon. So if we observe this bond angle as well as the bond length, these are nearly similar. So there is no much changes in conformational analysis. So there is no much difference in conformational analysis of the cyclohexane as well as morpholine and piperidine. Cyclohexane, morpholine and piperidine. No much difference in conformations of these three. But one more important difference is that the hydrogen present on nitrogen prefers axial position. So this axial preference is due to the reason for this axial preference is that the lone pair present here, this lone pair prefers equatorial position, because the lone pair interact with axial hydrogens, as well as axial hydrogens. due to which it prefers equatorial position. Prefers equatorial position. Equatorial position. So this is about the 6-member heterocyclic rings with nitrogen and oxygen. They are generally biparity, where nitrogen is there, and morphine, which contain nitrogen and oxygen. And see here cyclohexane ring. So in these 3 rings, if we observe the bond length is similar, nearly similar for carbon-carbon, carbon-oxygen, carbon-nitrogen. Similarly, bond angle is also similar. Carbon-oxygen, carbon-nitrogen, carbon. So there is no conformational difference between these 3 structures. These 3 they are similar to cyclohexane. So that's why conformationally they are not different. But important major difference is that the hydrogen present on nitrogen prefers axial position, because when the lone pair present in the axial and hydrogen present in equatorial, the interaction is there between axial hydrogens and this lone pair. This lone pair interacts with axial hydrogen presents here. So this axial hydrogen is there, this axial hydrogen there. When lone pair is in axial position, then it interacts with these axial hydrogens, and due to axial hydrogens interaction, it prefers to present in a equatorial position, and due to which hydrogen goes in a axial position. So this is about the 6-membered heterocyclic rings with nitrogen and oxygen. Thank you.